Hello guys, let us look into post-order traversal today. So for completeness of this video, I will also walk you through how do you represent a tree node given a problem like this. You should be able to quickly represent a tree node contains three properties. One is the data of that node, and it also contains two children, left and right. So this tree node represents a binary tree or a binary search tree. So if it is a tree with contains more than two nodes, you should have a list of tree node as children. So that's far and beyond this problem. Let's go into post-order traversal. So post-order traversal, where post-order traversal is used? Post-order traversal is used to solve expressions. For example, the in between root nodes are all operators, and the leaf nodes will be operands. So if given a tree node like this, okay, I would before explaining you how operators and operands will look like in a binary in an expression tree. Let's look into the post-order traversal algorithm itself. So post-order traversal traverses the tree in a way it traverses the uh, left, it traverses the right, and then it goes to the root. So it takes the first element, it takes the second element, it applies the operator on top of it and puts the result over there. So if that itself is a left or a right element, it takes that element and it takes the other element, it applies the operator on top of it and proceeds the value over there. So it keeps doing this, and finally when you reach the root, you get the entire expression tree gets resolved to a value. For example, it would be like if the left is 1 and the right is 2, so and the root would be star. So finally the result will be for example, if 1 is 2 trivial, right? So 3 into 2 is 6, or 3 plus 2 is 5, and then finally if that contains another node, so you put root left, right. So this is how an expression tree gets resolved. So let us run this code, and then I would walk you through a different way. So what we do is 2 is the root node, 2's left is 1, 2's right is 4, and 4's right is 3. So we represent the tree like this, right? 2 which goes to 2's left is 1, 2's right is 4, and 4's left is 3, I think. 4's left is 3. So how do we traverse this tree? It goes to the left, and then it goes to the right, and it goes to the left. It is the 2's left is 1. It does not have any child nodes. It goes to the root. It goes to the right part of the tree. It also contains the children. It visits the left, and its right is null, so it doesn't go print there. It goes to the 4 and it prints 2. This is how the tree traversal works. It is little confusing, so probably I will walk you through the same code again, with the same example. We get 2 as the root node here, and it goes and visits the left, right, and then the current, the root value. 2 contains a left node, it goes and visits 1. Visits 1, it checks if it contains left or right. So it does not contain left or right, so it visits 1, and it gives back to root, and it goes to the right part of the tree, which is 4. It checks if this contains left or right. It contains left, so it goes to 3, and 3 does not contain any left or right, so it prints 3. It goes up, it checks whether it has right. It doesn't contain right, it prints 4. and it goes back to 2 and it prints 2. That's how you get the result 1342. So I hope I have explained this. Uh, so as usual, I have used the lead code signature to solve it. If you do not want to use this kind of signature, we can use void public void post order of tree node root. If root equal to null, return uh, post order. First what we need to do is post order of, first we need to visit the left node, root dot left, then we need to visit the right node, post order of root dot get right, and then we need to visit the current node. I put visiting as printing root get well. So here I put system out println postorder traversal dot postorder of root. Let's run this again to see both the results are matching. Okay, 1342 1342. So for understanding purpose, I would recommend you to look into that, and then finally look into how do you add it to an array list, because bringing in array list again complicates the understanding because you are doing recursion on this. I would recommend to understand how do we traverse things, how do we do simple problems in recursion before visiting it, like Fibonacci and other things. So I would recommend first Fibonacci and then do all in order pre-order traversals and take complex problems in recursion. This helps you to think intuitively on when a problem is given, how do we solve it in recursion. Thanks for your time. Let's meet in a different video a different time.